For the first part, we imported abalone dataset containing 4,177 samples. The dataset includes 8 features such as sex, learns, weight, and others, capturing the physical characteristic of abalones. The target variable rings is used to estimate the abalone's age, with the formula age equal to rings plus 1.5 years. Fortunately, the data set was clean with no missing value or duplicates, so we could just dive right into the analysis and modeling stage without needing extensive cleaning. For next part, EDA. During the EDA, we examined the data set's structure and quality. It includes 7 numerical features and 1 category features, 6. The categorical variables was well balanced across its 3 categories: male, female, and infant. For the target variable rings, the distribution was slightly right-skewed, clustering between 7 and 12 rings, indicating most abalones fell within these age range. The continuous features such as hallway and height exhibit noticeable skewness and outlier, particularly in height, which had extreme value that needed attention. Correlation analysis revealed strong positive relationship among features like learns, diameter, and shell width. While these correlations are promising the predictive power, they might lead to multicollinearity issues that require dimensionality reduction. To process sex, we use label encoding, mapping the categories to numerical value. Outliers in the target variables were identified using the Tukey rule, and we visualized these using box plots. While these outliers could provide insights into unique samples, we might also hidden model performance, so careful handling was considered. For the feature importance part, to determine which features contribute the most to predicting the target variable, we use a random forest model, which is inherently well suited for the task due to its ability to rank feature importance effectively. The dataset was first split into training set and the test set. We used 80 to 20 split and scaled it using minimax scaler and standard scaler to standardize feature magnitudes. The analysis revealed that weight-related features were the most predictive of the rings. Specifically, shell weight ranked highest in importance, followed by visceral weight, sucker weight, and the whole weight. These features likely correlate closely with the abalone's age due to the relationship with the organism growth. Meanwhile, features like length and diameter had moderate influence, and sex had minimum impact. This finding aligned with the biological understanding that weight characteristic more than linear dimensions reflect an abalone's maturity, making these features critical for predictive modeling. And for the next part, baseline, we evaluate multiple regression models to predict the target variable range. The dataset was aligned split into training set and the test set, just like before, 80-20, and the feature was normalizing and standardizing. This pre-process step ensured the model sensitive to feature scale, such as linear regression, performed optimally. Among the models, linear regression and ridge regression stand out as the most effective. Each achieve an R-square value of 0.53 and an MSE of 5.1. These models effectively explain around half of the variables in the data, balancing simplicity with predictive power. On the other hand, Lasso regression performed poorly with an R-square of just 0.14, indicating that it struggled to selecting meaningful features in the dataset. On the other hand, like KNN and SVR demonstrate moderate performance with a R value of 0.5 and 0.41 respectively. While this model captures some patterns in the data, they did not outperform the linear models. Decision tree, tough flexible, show clear signs of overfitting and achieve only an R value of 0.2. Lastly, the MPL completely failed, delivering flat prediction with a negative R value, likely due to insufficient tuning. This result highlights the reliability of simpler interpretable models like linear regression for this dataset, particularly when computational efficiency and interpretability and priorities. Tree-based model and neural networks may require further tuning or additional data to improve their performance. So from the analysis, weight-related features are key in predicting abalone age, which is vital for agriculture and harvesting decision. Simpler models like linear and ridge regression work well for this dataset, offering a solid baseline with efficiency and interpretability. Future improvements could focus on handling outliers, dimensionality reduction, and optimizing advanced models like random forests or neural networks to boost accuracy and uncover deeper insights.